Welcome to lesson 2-2, solving one-step equations. I'm going to try to keep this really short because I think for most of you this should be a pretty good review. So I'm going to go ahead and keep this short. And there's a couple of key concepts today. The addition property of equality. So that states that adding the same number to each side of an equation produces an equivalent equation. So algebraically, we show it right here. X minus a equals b. Then x minus a plus a would equal b plus a. So algebraically, it's showing that if we add a to both sides, we still have equivalence. And then here's an example with numbers. So we have 7 minus 3 equals 4. So kind of like our x minus a equals b. 7 minus 3 equals 4. Then if we do 7 minus 3 plus 3, that would be the same as 4 plus 3. And then we show how it works. So kind of what I'm getting at is these two, a negative 3 and a positive 3, would add to 0, leaving us 7 on this side, and then 4 plus 3 over here is 7. So that's our key concept today. So if we add something to one side of an equation, we have to add it to the other side. That's all that we're saying. So here is the next key concept. There are 4. These two kind of go together, though. The subtraction property of equality is just similar to the addition property of equality, but it's subtraction. So it's the same idea. If we have x plus a equals b, then if we subtract a from both sides, if we subtract a here and subtract a here, we should come up with something that is equivalent. So here's our example, 4 plus 8 equals 12. So then if we subtract 8 from both of those, this positive 8 and this negative 8 add to 0, leaving us with 4 over here, and then 12 minus 8 equals 4. Okay, so we know that 4 plus 8 equals 12. Those two things are already equal. If we subtract 8 from both sides, we still have something that's equal. It's just not 12 anymore. It's 4 equals 4. So that's the subtraction property of equality. Again, this is most likely review. So here's what I'm kind of going to show you. X plus 7. So I want to know what plus 7 equals 4. Well, one way for me to know this is for me to undo the addition or subtract 7 from both sides. That will give me x plus 0, which is what I want. I take the positive 7 and the negative 7. Those things add to 0. And then over here, I have 4 minus 7, which is a really kind of strange number, but hopefully you all learned this in accelerated math, that 4 minus 7 will be negative 3. Okay, so that's the subtraction property of equality. It's just one step. We have to subtract what has been added to our unknown. We have to kind of get rid of it, so to speak. So, and then the next step would always be to check our answer and make sure it works. So we're going to put that negative 3 in for x, and negative 3 plus 7 is 4. And I'm just going to tell you throughout this chapter, this is critical right here. Checking your work is critical. When it comes to quizzes and tests, check your work, please. Okay, so here's our next example. We're going to probably use the addition property of equality and show you the horizontal format. I don't like the horizontal format. I like the vertical format, which I will show you later. We just did the horizontal format earlier as well. But since we are subtracting 12 from our unknown, to get back to my unknown, I've got to add that 12 back in. So now I have a negative 12 and a positive 12. So now basically I have x plus 0. I mean, technically, that's what I'm showing here is x plus 0 equals 3 plus 12. Okay, so x plus 0 is just x. 3 plus 12 is 15. So x would have to be 15, my original quantity. And that makes sense because 15 minus 12 does equal 3. And I'm sure the check is next. But here's the vertical format. I prefer this. Okay, I prefer the negative 12 and the positive 12. And I usually put it a lot closer. I write it like this, right up next to the like term that it would go with. And negative 12 and positive 12 add to 0. And then I have a 3 plus 12 right there. It's written just like I need it to be written. And I still end up with x equals 15. This is the method I prefer. I don't care which method you use. Okay, next key concept, multiplication property of equality. Same kind of idea. If we have x divided by a equals b, Then if I multiply both sides by this denominator a, as long as a is not 0, I am still equivalent. Notice I'm multiplying both sides by the same number, and it's my denominator. So let me give you a mathematical example. Oh, that's the division property. We'll go back. An example would be something like this. 12 divided by 4 equals 3. And if I were to multiply both sides of my equation by my denominator, okay, 4 in the numerator and 4 in the denominator, that divides out to 1. So we call it canceling out. But what they're doing is 4 divided by 4 is 1, leaving me with 12 over here, and 3 times 4 is 12 over here. Just showing you how it works with numbers versus letters only. And then obviously the next one is the division property of equality. Dividing each side of an equation by the same non-zero number produces an equivalent equation. So if a times x equals b, then a times x divided by a would also equal b divided by a, as long as a is not 0, because we cannot have 0 in a denominator. So I will give you a number or numeral example. If we have 5 times 7 equals 35, okay, and say I divide both sides by 5, okay? Right here, 5 divided by 5 becomes 1, leaving me with 7. And 35 divided by 5 is also 7. So you can see how, with numbers in it, the division property of equality does hold true. Okay? So here's our first example. Let's write our equation. We have -6 times x equals 48. So you guys, I know this is simple. You can ask yourself, -6 times what would give me positive 48? But I do want you to go ahead and practice this strategy just so that you understand it, because if you can do it when it's simple and you understand what you're doing, you'll be able to also apply this when it's much more difficult. So please just go ahead and do this, and we can see that the -6's divide out to become 1, which is what we want. We want to know what 1x equals. And 48 divided by -6 is -8. Okay, I have a feeling that they're going to do this, that my PowerPoint is going to do this, and it does. So I'll erase this. Okay, so we're dividing both sides by -6 because that is my coefficient of x. Okay, and then there's our answer. And we want to always check. I did not check. So I'm going to plug it back in. -6 times -8 equals positive 48. That's a question. Does it equal? -6 times -8 is positive 48, and it does equal 48. Okay, you can pause this video, do the guided practice, and bring any questions you have to class. Do those 4 problems, and you can restart the video and check your answers. Okay, if you don't understand how I got any of those 4 answers, circle them, and you can bring those questions to class. Okay, let's use some multiplication. We have x divided by 4 equals 5. I am going to take my denominator, and I'm going to use my denominator and multiply both sides by that denominator. So I'm going to multiply both sides by 4. Again, my 4's divide out to be 1 because this one is like 4 over 1. So it becomes a 4 in the numerator over a 4 in the denominator, divides out, and I get x equals 20. Let's check it. So put 20 in for x, and 20 divided by 4 equals 5, and that does check because 20 divided by 4 is 5. So again, pause the video, solve, and check. Okay, again, if you don't understand how I got any of those solutions, please bring your questions to class. Okay, the last thing I want to do is if we have a fraction as a coefficient versus just having 3 times x or -6 times x. What if we have 1/2 times x or 2/3 times x? So we're going to use a reciprocal. Well, what is a reciprocal? A reciprocal is an inverse, or you can write out here, write the word opposite. Inverse means kind of like the opposite. And an inverse is the number that will make another number multiply with it to get 1. So for example, the reciprocal of 2 is 1/2. So basically you take your numerator and your denominator and you flip them over. And you want to get a positive 1. So 2 over 1 times 1 over 2. Again, just show it multiply straight across. Like 2 times 1 is 2. 1 times 2 is 2. And 2 over 2 is 1. So a reciprocal is two numbers that multiply together to get a positive 1. Okay, so the reciprocal of -4/3 is -3/4 because my negatives need to cancel out to give me that positive 1. So I can multiply those together. 4 times 3 is 12. 3 times 4 is 12. I can say my negative times a negative is a positive, which again equals positive 1. So now let's see how we can use reciprocals. So what I can do here, instead of dividing by 2 and then multiplying by 7, I can just use the reciprocal. So I'm going to write the equation. Actually, I'm going to look at the coefficient, -2/7. I'm going to find the reciprocal, which I'm just going to tell you is -7 over 2. Now the negative can be with the 7, the negative can be with the 2, or the negative can be out front. But you can only have one negative somewhere in your problem. You cannot have two negatives because then it would make it a positive. Okay? So the reciprocal of negatives, I have it backwards, I'm sorry. The reciprocal of -2/7 is -7/2. That should be flip-flopped around. Okay? So now I'm going to use my reciprocal and multiply both sides by that reciprocal. And let me show you what happens. The two negatives become positive. My 7, one in the numerator, one in the denominator, divide to 1. My 2's, one in the denominator, one in the numerator, they divide to 1. So everything here comes out to a nice positive 1x. Now, do I have to write the 1 in front of the x? No. I'm just showing you why we use the reciprocal. Because we want to find out what 1x is. Not what -2/7 x is. We know what -2/7 x is. We need to know what just 1x is. So now I multiply -7/2 by 4, and I get -7 times 4 is -28 over 2, which simplifies to -14. Okay, so there's my simplification, -14. And then I would want to substitute that in to check. Okay, -2/7 times -14. 7 goes into 14 2 times. And -2 times -2 is +4. So it does check. Okay, stop the video, do 2 of these problems, and then check your answers. Okay, I just want to tell you, they're not always going to come out these nice whole numbers of 12 and 10. They may come out a fraction, and that's okay. All right, we're going to skip this. I'm going to let you go ahead and bring your notes to class. We will do this in class tomorrow, and we'll do our assignment after we do this in class. That's the end of the video. Have a good night. Good night.